All right, so here's our practicum problem. We've got a little gantry crane, uh, 24 feet tall, about 20 feet wide, carrying a load of 10,000 pounds, 10 kips. We've got three members making up this frame. We've got member AD, the vertical member. We've got member CE, the horizontal member, and member BE, slanted member. It's got a pinned support down here at the bottom of A, and it's got a roller support resting up against a wall at point D. So we've got our table set up here. We've got four pinned supports. We've got A, B, C, and E. Those are all pins, so they'll have both an X and Y reaction. The roller support at D will only have a reaction in the X direction. So we've got only the X box available there. That means we've got a total of 9 unknowns. So we've got 2, 4, 6, 8, 9 unknowns, which means we're going to need 3 sets of 3 equations to make this work. The approach I'm going to take on this one is I'm going to do the external problem first. That'll get me my reactions at A and D. And in fact, I'll get numbers for those because we get 2 reactions from A and 1 from D, 3 equations, 3 unknowns. So we have 3 numbers that we'll get. And then I'm going to work the vertical and the horizontal members. So I'll draw the free body diagrams for the vertical and the horizontal members and work those. Those will give me the other 2 sets of 3 equations and let me get the other 6 unknowns. So let's start with the free body diagram for the whole frame. So I'm going to replicate that over here on this page. I've got my vertical member, the horizontal member, and that cross support. We've got 10 kips here. At A, I've got 2 forces, RAY and RAX. And then up here, I've got this roller. And since the force that the roller exerts is perpendicular to the surface, I'm going to draw that off like this. That's RDX. Got my coordinate system. To the right is positive, up is positive, and counterclockwise moments are positive. And I'll take any geometry I need from the original drawing. So in fact, maybe we'll just kind of keep that over here. So there's my free body diagram. So we've got 3 equations we can work with here. We've got our sum of forces in the X direction, and I've got a negative RDX. I've got a positive RAX, excuse me. No other forces in the X direction for the external problem. So that sum's equal to 0. I've got a sum of forces in the Y direction. I've got a positive RAY and a negative 10 kips. And that equals 0. And then I've got moments about a point, and I think I'm going to pick point A as my pivot point. That means no moment from RAX or RAY. I will get a moment from RDX, and I will also get a moment from the 10 kip force. I just need to have the arms for those. RDX, according to my diagram here, is 24 feet away from A. So I've got 24 RDX. If I'm pinned at A and I'm pulling to the left with RDX, that's a counterclockwise moment. So that's positive. Then I've got 10 kips, and according to my drawing, that 10 kips is 20 feet away. So I have 20 times 10. Pinned at A, pulling down where the 10 kip force is, that'll give me a clockwise moment. So that's negative. So the moment equation I should be able to solve here. I've got 24 RDX minus 200 equals 0. Add 200 to both sides, and I've got 24 RDX equals 200. Divide both sides by 24. And R dx comes out to be 8.3333 kips. So RDX has a value of 8.3333 kips, and I'm going to keep 5 significant figures in my intermediate calculation. In the end, I'll round my final answers, my magnitudes, off to 3 sig figs. So RDX, we had 8.3333, and the kips is up there in the header of the table. For the y direction equation, that one's pretty easy to solve. Add 10 to both sides, and RAY is 10 kips. So we've got another value we can plug into our table. RAY is 10 kips, and there was no rounding there, so I'm not going to write that as 10.000 or anything like that. It was exactly 10 kips, so I'm just going to leave it like that. And then we've got our x direction equation. Well, I have my value for RDX, so I can plug that in there. Just be careful of that negative. It's negative whatever the value of RDX is. RDX was 8.333, so I have negative 8.3333 plus RAX equals 0. If I add 8.3333 to both sides, that'll give me RAX is a positive 8.3333 kips. So that gives me another value I can fill in here. So I've got 8.3333 kips. So there we go. We've got 3 out of 9 of our unknowns. Now to get any further information, now we have to break the frame apart. So there was the work there for the external problem. To break the truss apart, I'm going to draw 3 separate free body diagrams. So we've got 3 members. I've got the vertical member, I've got my horizontal member, and then I've got this cross piece. Those are my 3 free body diagrams. At joint A, going back to my original external free body diagram, I had RAX and RAY. Being careful here to use the same directions I used there. And RDX up here. But now that I've got this blown apart, I've also got this joint here at C and this joint here at B. On the horizontal member, I've got joint C here, I've got joint E somewhere around here, and then I've got that 10 kip force there. And then I've got joint B down here and joint E up there. So to draw my free body diagrams, I've got to expose the forces at these points, at these joints B, C, and E. Those are the internal joints to the problem, and they're the ones I have to be careful in labeling out to make sure I keep everything consistent. So I'm going to follow my basic rule, which is that the first time I use a joint or I see a joint in the problem, I'm going to label it positive, X and Y. And then the second time I see it, I'll label it negative. That way it'll ensure the pieces all fit together. So it's taking into account Newton's third law, equal and opposite reactions. So joint B in the vertical member, it's the first time I'm dealing with joint B. So I'm going to call it RBX and RBY. Joint C, same deal. First time I'm seeing it, so I'll say RCX and RCY. If I go over to the horizontal member, I've seen joint C before. I've already made some assumptions about joint C. So I've got to assume the opposite. RCY is down and RCY is to the left. That's taking into account RCX is to the left. That's taking into account Newton's third law, equal forces but opposite in direction. E I haven't made any assumptions about yet, so I'll draw it positive. REX REX and REY. Now, I already know I'm only going to use the vertical and the horizontal members, but if I wanted to use the slanted one, I'd have to draw the directions correctly. And since I've already made some assumptions about B, I'd have to say RBX and RBY negative. And same thing at E. I've already used E once in the horizontal member, so I'd have to do REX and REY. There. But I'm only going to use the horizontal and the vertical members, since horizontal and vertical members are the easiest ones to work with. Slanted members are a challenge. Not that you can't do it, but it's harder to work with. So let's deal with the vertical member first. So I'll copy over the free body diagram for the vertical member. I've got RDX, which I already know, but I'm going to leave it as a symbol right now. I'll fill in that information after I build the equations. Got RBX and RBY. And then I've got RCX and RCY. We've got a 10-foot distance here. $20 feet to there, and then an additional 4 feet, just to get the geometry copied over. So let's do the equations of equilibrium, sum of forces in the x direction. Now we already know here, if you look ahead a little bit, I've got numbers for RAX, RAY, and RDX. So those are knowns. But I've got 4 unknowns here, RBY, RBX, RCY, and RCX. So although I'm going to be able to come up with 3 equations, I might not get numbers for all of those unknowns. I'm not going to get 3 numbers out of this. If I'm lucky, I'll get 2 numbers in an equation. If I'm unlucky, I'll get 3 equations. But I'll have at least 3 pieces of information that I'll be able to carry forward. The sum of forces in the x direction, I've got RAX positive. I've got a negative RDX. But then I've also got a positive RBX and a positive RCX. Nothing else in the x direction, so that sum's equal to 0. If I take my sum of forces in the y direction, I've got a positive RAY, I've got a positive RBY, and a positive RCY, and that's all equal to 0. And then I've got moments about a point, and just like in the problems we did in the lecture, always a good idea to take your pivot point around one as one of the unknowns. So either point B or point C. I'm not going to take it around A because that'll give me 2 unknowns in my moment equation. I'm not going to take it around D. It'll give me 2 unknowns. If I pick joint C here, I'll knock out RCX and RCY. I'll also knock out RBY and RAY, since the lines of action of all those forces go through C. I will get a moment from RAX, but that's not too bad. I know how far away that is. I'll get a moment from RBX, but I know how far away that is. And I'll get a moment from RDX. That's not too bad. 2 of those are numbers. So let's figure those out. Let's go from top to bottom here. I've got RDX, but pivoting at C, that's 4 feet away. So I have 4 RDX. And pivoting at C, pulling to the left at D, that's a counterclockwise moment, so it's positive. RBX is 10 feet away. It's 20 feet to the bottom, and then B is 10 feet back up, so it's 10 feet. Pinning at C and pulling to the right at B will cause a counterclockwise moment. so it's positive. And then I've got RAX. RAX is 20 feet away. Pinning at C and pulling to the right at, or pushing to the right at A will cause a counterclockwise moment, and counterclockwise moments are positive. So there I've got my moments. 3 terms in the moment equation, one from RAX, one from RBX, and one from RDX. So it's looking kind of ugly at this point, but we've got some numbers we can fill in. If we go back to our table, I know RAX, I know RAY, and I know RDX. So let's fill in what we know. We've got 8.3333 for RAX. We've got 8.3333 for RDX. Don't know RBX, don't know RCX. So that makes our X equation a little nicer. The 8.333's cancel out. So we get a bit of a simpler equation. In the Y direction equation, RAY is 10. So I have 10 plus RBY plus RCY equals 0. If I subtract 10 from both sides, that gives me a little bit nicer equation. I've got RBY plus RCY is negative 10. And then I've got 4 times RDX, so 4 times 8.333 plus 10 RBX plus 20 RAX equals 0. So that's a little bit more complex, but at least it's numbers. We've got 4 times 8.3333. That's 33.3333 plus 10 RBX plus 20 times 8.3333. That's 166.67 equals 0. If we combine the numbers together, we get 200.00, or just 200. So we get 10 RBX plus 200 equals 0. Subtract 200 from both sides. 10 RBX equals negative 200. Divide both sides by 10, and RBX equals negative 20. So there we've got a number we can work with. We can go and fill that into our table. RBX is a negative 20. Now that helps us out here too with our X direction equation. RBX is a negative 20. Negative 20 plus RCX is 0, so that must mean RCX is a positive 20. If we add 20 to both sides, RCX is a positive 20. So we can fill that in. RCX is a positive 20. Unfortunately, though, we don't have RBY and we don't have RCY. So we're left with an equation. We have 2 numbers and 1 equation. About the best we could hope for with 4 unknowns and only 3 equations. So I'm going to copy that equation over onto my table, or at least underneath it. I'm going to say RBY plus RCY equals negative 10. So there's the work for the vertical member. We had 4 unknowns and 3 equations. We got 2 numbers. RBX is negative 20 and RCX is positive 20. But we got 1 equation that we can work with, 1 relationship or constraint between 2 of our unknowns. RBY plus RCY must equal negative 10. Nothing more we can learn from this particular free body diagram, so we've got to move on to another one. And this is where we'll pick up the horizontal member. So let's go ahead and draw the free body diagram of the horizontal member. Here's my exploded view of the frame, the horizontal, vertical, and slanted members. I'm going to go and draw the horizontal member. I've got RCX and RCY. I've got REX and REY. And then I've got 10 kips. So there's the horizontal member. And we can build up our equations of equilibrium. The sum of forces in the x direction. I've got a negative RCX. I've got a positive REX. That equals 0. Sum of forces in the y direction. I've got a negative RCY. I've got a positive, REY. And I've got a negative 10 kips. That equals 0. And then I've got moments about a point. So I have to look at what pivot point I want to use. And because I know about things that are going on at C, well, because I've got my distances measured at C, should be okay. I'm going to knock out, whether I pick C or E, I'm going to knock out everything except one unknown anyway. So we may as well pick C. So we'll pick C as our pivot point. The distance here to the end of the gantry is 20 feet, and we have 10 feet to there. So about C, we're going to knock out RCX and RCY. We'll also knock out REX. The only forces that'll have arms, will have moments, will be REY and 10 kips. So the REY force is 10 feet away, so we have 10 REY. Pinning at C, pushing or pulling up at E would cause a counterclockwise moment. Counterclockwise moments are positive. And then 20 feet away, we've got 10 kips. If we're pinned at C and pulled down where that 10 kips force is, that's a clockwise moment. Clockwise moments are negative. So there's our moment equation. We've got 10 REY minus 200 equals 0. If we add 200 to both sides, we have 10 REY equals 200. Divide both sides by 10, and REY is 20, and that would be kips. So now we've got another value we can plug into our table. REY is 20 kips. We can also go back up here and plug in that if REY is 20 kips, we've got negative RCY plus 20 minus 10 equals 0. 20 minus 10 is 10. So we have negative RCY plus 10 equals 0. Subtract 10 from both sides. I have negative RCY is negative 10. Divide both sides by negative 1, or multiply both sides by negative 1, whichever you prefer to do. Positive RCY is a positive 10. So RCY is a positive 10. So we can fill that into our table too. RCY is positive 10. We've got RCX already from our table. We know RCX is 20. So we have negative, whatever the value of RCX is, negative 20, plus REX equals 0. Solving that one, REX is a positive 20. So that's another one we can fill into the table. Now we've only got one missing space here. We've got RBY. That's where we can go to our equation in reserve. our by plus our cy is negative 10. We just figured out our cy is positive 10. So our by plus 10 is negative 10. Subtract 10 from both sides, and our by is negative 20. Negative 10 plus a negative 10. So we get negative 20. So there's the horizontal member work. We were able to get numbers out of each of those equations, and then we were finally able to use that equation we couldn't use from the vertical member. So let's wrap up the problem by finding our magnitudes. And because my magnitude is my final answer, I'm just going to read it off from the calculator after I take the square root of x squared plus y squared. I'm going to round that off to 3 significant figures, since I want my final answers in this problem to be to 3 sig figs. So in the first one here, we'll take 8.3333. We'll square that, add that to 10 squared, and take the square root. We get 13.0. We have 20 squared plus 20 squared. Square root is 28.3. Notice the magnitudes always come out positive, because when you square any number, positive or negative, it's going to be positive. So the only thing you could ever take a square root of here would be a positive value. The answer's got to be positive. So just ignore the negatives here when you're doing your magnitudes. It'll save you a lot of trouble if you have issues with your calculator. We have 20 squared plus 10 squared. There we get 22.4 kips. For D, we only had one component. We don't have a y component, so we can just carry that over, 8.33. And then we've got 20 squared plus 20 squared. That was the same as what we had with B. So we have 28.3. So there we go. There's our final answer. And that's the problem.